So this question is about the way that you can apply vectors in various equations, where we have to remember that vectors have multiple components that tell you the direction of something. So this equation here looks like one equation, but really it's two equations in one. One of them is in the x direction, and one of them is in the y direction. So if we look at the x components of these vectors, it says that m and n are a constant. So we would have m times the x component of the s vector, which is 2, plus n, which is also a constant, times the x component of the t vector, which is -6. And that should be equal to the x component of our final vector, which is -16. So right now we can't solve for either m or n because right now we only have one equation with two unknowns in it. So then we need to look at the y version of this equation, which would give us m times the y component of vector s, which is 3, plus n times the y component of vector t, which is 1. And that's supposed to be equal to the y component of the final vector, which is 6. So now we have two equations with two unknowns, m and n. So solving for this is a system of equations. We could either do substitution or we could do elimination. Elimination looks faster here. So I'm going to take the y equation and I'm going to multiply both sides of it by 6. So I'm going to leave the x equation alone. I'll just rewrite it down here. So 2m minus 6n equals -16. That's the x version of the equation rewritten. And then the y version, when looking at the y components, when we multiply both sides by 6, would give 18m plus 6n equals 36. And then we can easily just add these equations together to get that the -6n and the 6n cancel, and we're left on the left with 20m equals 20. So divide both sides by 20, and we get that m is equal to 1. Then when we continue, we want to get n as well. So we would need to plug m into either equation. I'm going to plug it into the first equation. So 2 times m, which is 1, is equal to, minus 6 times n, which I don't know, equals -16. So now when we solve for n, I'm going to add 6n to the other side and then also add 16 to the left. So that would give me 2 plus 16 equals 6n. So 18 divided by 6 would give me n is 3. So that's how you would solve for both of those constants using a system of equations. One equation in the x, one equation in the y. This looks like one equation, but since these guys are vectors, s and t are vectors, so that means that you actually have two equations hidden inside there. And then for b, this works the same way. S and t are still vectors. So we are going to have two versions of the equation. We're going to have an x equation and we're going to have a y equation. The x one would be the constant p, which we're looking for, times the x component of s, which is 2, plus the x component of t, which is -6. And this is supposed to be equal to the x component of the final vector, which is 0. So from this, we can already solve for p because that's the only unknown in here. So p is going to be 3. And then the y version of the equation would be p times the y component of s, which is 3, plus the y component of t, which is 1, equals q. And here we can plug in the fact that we know p is equal to 3 because we already used the x version of the equation to get that. So then we know that q is equal to 3 times 3 plus 1, so 10. So now we know p is 3, and we know that q is 10. So that's how you would solve these vector equations.